and welcome to the second week of lectures in sustainable energy technology. So today we will discuss about the impacts of traditional fossil fuel based energy sources, and we will try to understand why they are not sustainable in the medium term as well as in the long run. That is why we are trying to go for an energy transition process in the first place. Only once we understand that, we will be able to understand what is the advantages in terms of sustainability and renewability for the new types of energy technologies that we will be discussing over the latter parts of this course. So on that note, let us begin our class today. So as we discussed, our main topic for this lecture is the impact of fossil fuels on regarding why fossil fuel based energy sources are proving to be unsustainable in today's world. So here there are two aspects by which fossil fuel energy use has proven unsustainable or having a harmful impact both on the environment and for the future of human society. The first is through pollution formation. So the idea here is most of the fossil fuel energy sources generate energy through combustion processes. That is, they are hydrocarbons, and when they burn, they produce a significant number of pollutants in sufficient quantities to cause harmful effects to human health. So some of these pollutants include, and we will learn more about them during the course of this class, include ozone, particulate matter, nitrogen dioxide, nitrogen oxides, which we call NOx, sulfur dioxide, and other types of pollutants. And among these pollutants, they have multiple impacts on human health. So BAP is primarily a kind of a plastic pollutant. So we will not discuss this in this context because fossil fuel energy does not produce that. But the other forms are produced by the fossil fuel based energy source generation processes. So they cause irritation of eyes, nose, throat, breathing problems. So as you know, in India, especially in the urban areas, pollution caused by cars, vehicles, the smoke, the smog, the particulate matter, etc. has been a major health issue for many decades now. And many of you might have had first-hand experience of this. If you are living close to cities or close to busy areas where there is a lot of industrial energy generation, or where furnaces are being used, as well as in near heavy traffic areas where a lot of pollution or tailpipe emissions happen for cars, trucks, etc. So many of these pollutants do cause irritation of eyes, nose and throat, breathing problems. They can cause headache and anxiety and also impact the central nervous system. They are one of the major causes of respiratory system infections, irritations, asthma, allergies, reduced lung functions and pulmonary diseases. Then they can also be the cause or the catalyst for cardiovascular diseases, that is heart diseases. They may impact liver, spleen and blood as well as reproductive systems. So the impact of these pollutants, and there are various types of them, actually have harmful effects on all aspects of human health. Recently, in the last 10 years, there has been a systematic study that helps us quantify the number of premature deaths that can be directly attributed to air pollution. Okay, so here by premature deaths is because deaths that has been caused by diseases that have been triggered through air pollution impacts. Okay. So typically what happens, deaths are either due to heart attack or lung infection or breathing problems, different aspects. But what these types of studies try to show is that those primary causes of death, heart attack, lung infections, are actually being happening due to air pollution impacts, right? So the air pollution is the driver of these premature deaths, right? So this is a study on the global ranking of risk factors by total number of deaths from all causes in the 2019, okay, number of premature deaths. And here if you can see, of course, there are traditional causes like high blood pressure, that is a problem in stroke, heart attack, etc. Tobacco, that is cigarette smoking. Dietary risks like diabetes. Those aspects are the primary three causes of death. But air pollution is fourth on the list. All right, which caused around 6.67 million deaths worldwide in 2019 alone. So if you think of air pollution, it's the fourth leading cause of death in the world today. And there is also studies that show what is the percentage of diseases that can be attributed to to air pollution. Okay, so for example, 20% of diabetes cases are attributed to metabolic changes caused by air pollution. Okay, lung cancer, 19% of it is caused by air pollution related triggers. Pulmonary diseases, 40% of this is obstructive pulmonary disease, COPDs. Okay, 20% of neonatal deaths can be attributed to air pollution. So as you can see, many of the leading causes of deaths in today's world, a significant chunk of it is actually triggered through air pollution related illnesses. This is kind of another metric here where the geographical distribution of air pollution related deaths have been mapped in 2017. This is a 2017 study, and the reds and the yellows are where the air pollution related deaths are maximum, and the blue are the regions where the air pollution related deaths are minimum. Okay, so here the maximum air pollution related deaths are seen in India and China. So overall, so this is 2017, 5 million deaths were attributed in 2017 to air pollution worldwide, and of that around 1.2 million deaths happened in India and around 1.3 million deaths happened in China. So India and China together was responsible for half of the air pollution related deaths throughout the world. Okay. And this is something primarily due to the extent of air pollution is particularly high in these countries because of the heavy fossil fuel based energy generation processes that are happening in these countries. Okay. And also lower amount of adoption of clean air technologies in these countries. Okay. So particularly then you can see that India suffers from a significant deaths and mortalities due to air pollution and is one of the leading causes of death in India. So here you can see the distribution here. So 69% of total air pollution related deaths are happening in Asia, okay, and only 31% elsewhere. And among the deaths attributed to air pollution, indoor air pollution is also a significant chunk of deaths that are happening. All right. So this is also something that that is sometimes overlooked. Yes, industrial pollution and vehicular pollutions cause outdoor or external air pollutions do cause deaths, but indoor air pollution due to use of traditional wood-based ovens, wood-based cooking stoves, they cause a lot of smoke generation which is inhaled, and this also causes a lot of air pollution related deaths. So those are also an important aspect of deaths that are happening worldwide, particularly in India and China. So then we can discuss what are the main types of pollutants that exist in the world that are caused that is causing these deaths. Okay. So the first series of pollutants we are calling NOx, NO suffix X. This is a mixture of various types of nitrogen oxides. Two primary types of nitrogen oxides are NO and NO2, nitric oxide NO and nitrogen dioxide NO2, and these are caused these are produced during the combustion process when the nitrogen of air reacts with oxygen of air at high temperatures in flames caused during the combustion process of fossil fuels. And these are harmful to respiratory systems and to eyes, causes acid rain. So nitric oxide and nitrogen dioxide can dissolve in water in the rain to produce nitric acid and nitrous acid, which causes acid rain and is also an important component of smog. We will discuss more about smog very soon. So the brown haze that is often there in the cities during the winter times, which we call smog, NO2, nitrogen dioxide, is a major component of that. Then you have SOx emissions, which is caused by the burning of sulfur in coal and heavy oils. So coal and heavy oils contain a little bit of sulfur, which burns with oxygen to produce sulfur dioxide and other types of sulfur compounds, which are also harmful to respiratory systems, and is a major contributor of acid rain because it can dissolve in rainwater to produce sulfuric acid and sulfurous acid, which is a major cause of acid rain to become acidic and harm the agricultural fields, ecosystems, and human health. Then you have ozone. So this is lower atmosphere ozone, not the stratospheric ozone, which is caused by the reaction of nitrogen dioxide formed initially in the presence of light to form NO and ozone. So nitrogen dioxide reacts with oxygen O2 in the presence of light to form NO and O3, and this produces ozone. And ozone is extremely harmful when it's inhaled because it's a highly reactive molecule. So it directly attacks lung tissue, aggravates asthma, and is carcinogenic. Carcinogenic means it causes cancer. It has a pungent odor and it's a pale blue gas. Another type of pollutant is what is called VOCs, volatile organic carbons. So these are caused due to incomplete combustion of fuels. So fuels are primarily hydrocarbons. So part of the fuel does not oxidize and instead they break down into smaller organic molecules that become suspended in air. So these are called volatile organic compounds. Another source of these VOCs is evaporation of sprays and organic aerosols. So all the types of organic aerosol sprays, deodorants, pesticide sprays, etc., they are also made of organic compounds. So when they evaporate, they add volatile organic components in the atmosphere. So many of these organic components, when inhaled, is also carcinogenic. So there is a lot of research going on right now on the impact of all the sprays that we use. For example, sprays during the painting of buildings, walls, etc. A lot of the wet paint kind of vaporizes and gets suspended in the air when we are painting houses, etc. So they are also quite carcinogenic and is harmful to human health. Then another type of pollutant is particulate matter. So these are primarily what you call soot, the black component in smoke that you see coming out of industrial chimneys or vehicular tailpipes. So these are basically partially burnt carbon atoms so many carbon atoms kind of clump together to form small particles of carbon which get suspended in air to produce the smoke or the soot. Okay, and this is caused again because of incomplete combustion of fuels. Okay, that is one source. Another source is inorganic particulate matters. So in places where there is a lot of construction activity, many of the cement particles or stone particles, when they are ground and produce fine dust, that also gets suspended in air. Okay, this we will see a lot near construction zones especially. So these kinds of suspended micron-sized particles of dust and soot. So dust is inorganic component and the soot is the organic component. And these are also extremely carcinogenic and causes respiratory illnesses. Finally, we come to acid rain. So we have discussed this before also, just during the course of this slide. So these are acids which are formed by the reaction of water droplets with NOx and SOx compounds that get produced by these processes. So sulfur dioxide reacts with water to form sulfurous acid. Nitric oxide reacts with water to form nitrous acid. So these are acids, so they decrease the pH of water to below 5.6. Remember, neutral water is around 7. So above 7 the water is alkaline, below 7 the water is acidic. So when these acids form, the raindrops pH drops below 5.6 and hence they become acidic. So when acidic rain falls on the ground, it decreases soil fertility because the soil microbial life that is important for the soil to remain fertile cannot tolerate these kinds of acidic conditions, and they die off. The vegetation dies off, increases erosion, damages crops and vegetation, pollutes water bodies and harms ecosystems. So acid rain is also a very big problem, especially where NOx and SOx emissions are quite high. Now, what is the contribution of energy related industries to the formation of these various types of air pollutants? Okay, so this is kind of an infographic that kind of gives you roughly the relative estimate of the impact of various energy sectors to the formation of these pollutants. So when you look at sulfur dioxide, 99% of sulfur dioxide emissions is coming from various types of energy related industries. So here the dark blue is power, so direct conversion of fossil fuel sources into electricity. So the power industry. Okay, so that is the dark blue region. Then the lighter blue region is basically basic industries where you are using industrial furnaces like steel making, ceramic industry, glass making industry, cement making industry, where you need fossil fuels as a source of heat to drive various industrial processes. So that those are the industrial sectors, and the emissions from the industrial sectors is the light blue. Then the green part is transport. Direct again emission of many types of pollutants happen from the transport sector. Then you have emissions from the building sector. So buildings also, so within buildings you have your cooking, so your cooking gas or your wood stoves in the villages, etc. Heating, many cold countries require heaters that are run in natural gas, and lighting. So the electricity can be used there, and how the electricity is being produced is also from the fossil fuels, right? Then there is also emissions coming from the production of fuels. So mining of coal, mining of petroleum, their storage and transport, those also often is a significant source of emissions. And finally, you have the non-energy sources like agricultural sources, aerosols from sprays, etc., and waste. Okay. So now if you look into this, sulfur dioxide, almost everything is from energy related industries, power generation, fuels, transportation, etc. Similarly, nitrogen oxides, NOx, more than 99% comes from energy related sectors. 85% of particulate matter also comes from various energy related sectors. 92% carbon monoxide, CO, also a toxic gas produced from energy sectors, is coming from there. 66% of volatile organic compounds also come from air. The only pollutant that does not come directly from energy related sources is ammonia, which is primarily from agricultural industry it is produced. Okay. So you see, majority of the harmful pollutants in the world are coming from energy related industries, whether it's power, consumption of fossil fuels by industry, transport, buildings, or events happening during the fuel production, supply and storage related issues. So here is kind of a brief infographic of how much emission happens from various types of fossil fuels. All right. So when we do a tutorial this week, we will go into a deeper analysis of the various types of emissions that are happening, how much is happening from various types of fossil fuels. So there are many types of fossil fuels, as you will be aware. You have coal, you have petroleum, you have natural gas. So these have different emission profiles. So it is not that 1 kg of coal will produce the same amount of pollutants in the same proportion as 1 kg of natural gas. That is not what happens. Okay. So here we are looking at a comparison chart from various types of fossil fuel sources. You have hard coal, which is basically good quality anthracite and bituminous coal. This is called hard coal. Brown coal is medium to low quality coal, sub-bituminous and lignite coals. So their quality is lower. So here in terms of quality, what it means is how much carbon it contains compared to how much ash, water, etc. So hard coal has higher carbon content and lower water and ash content, whereas brown coal has relatively lower carbon content and higher water and ash content. Then you have fuel oil. It's a heavy oil that is often used in industries for electricity generation or heat production. And then you have natural gas. Alright, so these are all primarily used for electricity generation or heat generation, right? So here that comparison is how many kgs of pollutant is emitted per gigajoule. That is, so giga is 10 to the power 9, right? 10 to the power 9 joules of electrical energy that is being generated. So how many kgs of a certain pollutant is being emitted per gigajoule of electricity generation out of these 4 types of fuel sources. So you have hard coal. As you can see, if you compare the CO2 emissions, so we will discuss why CO2 is a pollutant in the next class. It is related to global warming, so not because of toxicity to health in other aspects. And you can see that firstly, for both hard coal and brown coal, around 95 to 101 kgs of CO2 is emitted per gigajoule of electrical energy generated out of coal-based power plant sources, right? Compared to that, fuel oil, you are emitting less CO2 for the same amount of electricity generated, and for natural gas, you are emitting even less CO2 for the same amount of electricity generated. In fact, if you look between coal and natural gas generates only half as much CO2 by mass as coal for the same amount of electricity that gets generated out of a natural gas power plant versus a coal-based power plant. Which is why you will see in many places in industry, there is a discussion of transitioning from coal-based power plants to natural-based power plants to mitigate the amount of CO2 that is being emitted per unit of electricity generated. So it is not that all fossil fuels emit the same amount. There are cleaner fossil fuels and more polluting fossil fuels. And in terms of CO2 emissions, as you can see that natural gas is a significantly cleaner source of energy compared to coal. And fuel oil is in the middle. Now, if you see, the same situation is again happening when you look at sulfur dioxide, which is kind of the main component of SOx-based emissions. So here you will see that 0.76 to 1.36. So around 1 kg of SO2 is emitted per gigajoule of electrical energy generated from coal power plants. It's better for hard coal, somewhat worse for brown coal. So 0.7 to 1.6, 1.36. Okay. Compare that to fuel oil, which is just 0.23 kgs, and for natural gas it's 0.007. So this is around 7 grams. So only 7 grams of SOx is emitted, SO2 is emitted per gigajoule of electrical energy if you are using a natural gas based electricity generation process, whereas that value goes up to 0.76 kgs or 1.36 kgs if you are using various types of coal in a coal power plant. So here again natural gas proves superior. And the same situation is repeated for NOx. So around 0.3 kgs for hard coal and 0.18 kgs for brown coal, NOx is emitted per gigajoule of electricity. Fuel oil, it's 0.195, so very similar to brown coal. Natural gas, it's 0.09. Okay, so again significantly lower. Similar case for particulate matter. Hard coal, it's around 1.2 kgs. Brown coal is extremely polluting in this context. There is a lot of incomplete combustion due to the presence of moisture and ash. and you will get 3.2 kgs of particulate matter produced per gigajoule of electricity in brown coal. Fuel oil is significantly cleaner, 0.016, and natural gas is even cleaner, 0.001. So only 1 gram of particulate matter is emitted due to natural gas based electricity generation. So you see that if you are shifting from coal to natural gas, you will do significant amount of savings in terms of pollution emissions. So this is kind of a intermediate clean energy transition target for many industries, to shift from coal based heat generation or electricity generation to natural gas based heat generation or electricity generation. Now, if you look at vehicular emissions, and these are US 2009 estimates, so they are kind of obsolete, dated right now, but still it's a good indicator anyways. So here again, different vehicles and different fuel types emit different amounts. Okay. So for example, here we are looking at four types of vehicles. Gasoline is petrol, basically petrol, and diesel is diesel. So you have gasoline based two-wheelers, that is scooters, motorcycles, etc. Gasoline based car, that is petrol cars that you typically see. Then diesel based cars and diesel trucks. Okay, and this is the average one. So here the total hydrocarbon being emitted is, and this is per kilometer of travel if I am correct. I will just check the units once more, but this is probably per kilometer of travel. Okay. How many grams of each of these particulates is emitted per kilometer of travel is what these units are. Okay, but I will just double check this and clarify it in the final PPT that I will send you. So this is so if you can see here, two-wheelers emit more hydrocarbon, like unburned hydrocarbons. They emit compared to gasoline cars, diesel cars, or even diesel trucks. Okay, so this kind of shows that two-wheelers in terms of total hydrocarbon emitted is significantly less clean than other types of systems, and diesel trucks are the most efficient in this context. Okay. When it goes to carbon monoxide, you will see that carbon monoxide emissions are highest for gasoline two-wheelers and diesel cars, whereas it's least for diesel-based trucks, which are quite efficient in this context. Similarly, NOx emission, however, you will have significantly higher NOx emissions for diesel-based trucks, around 13 grams per kilometer of travel, compared to the other types of systems like gasoline two-wheelers, gasoline cars, or diesel cars. So diesel trucks are more cleaner in terms of hydrocarbon emissions and CO emissions, but not as clean in terms of NOx emissions. And in terms of PM 2.5, also a similar story is here. Diesel trucks are the highest, followed by diesel cars, and then gasoline two-wheelers, and then gasoline cars. Okay, so you can see that gasoline-based cars are the cleanest when it comes to NOx emissions and PM 2.5 emissions. However, it has reasonably high values for total hydrocarbons and moderate values for CO. Whereas CO and hydrocarbons are least for trucks, but they are the highest for NOx and PM 2.5. Okay. And vehicles emit around 200 grams of CO2 per kilometer of travel. This is an average car kind of an average, that 200 grams of CO2 is emitted per kilometer of travel by a vehicle.